Today we are going to see the surroundings of a monster black hole, up close for the first time ever. This is a unique opportunity because such black holes are surrounded by huge disks of glowing hot gas, and now we can study them like never before. Yes, this is a big deal. So let's have a look at the amazing new results together. To tell you the truth, these monster black holes were winking at us for quite some time already, but we only noticed them very recently. These mysterious winks are called QPEs, or quasi-periodic eruptions. They are sudden bright flares of X-rays coming from the vicinity of these monster black holes. Each wink is about 1.5 days long and happens regularly every few days for months or even years. But why do they wink? Well, that's exactly what we are going to find out today. We have only recently encountered this class of X-ray flares. Only 7 of them had been identified before, and all of them were somewhat similar. However, the 8th one just discovered is extremely different and is named Ansky. Astronomers know about it because of a paper published in April in the journal Nature Astronomy. That's where scientists reported about this record-breaking quasi-periodic eruption. Ansky is the brightest QPE source discovered to date and sets records in terms of timing and duration. Its eruptions happen every 4.5 days or so and last approximately 1.5 days. These QPEs are mysterious and intensely interesting phenomena, said Joheen Chakraborty, a graduate student at the Massachusetts Institute of Technology in Cambridge. One of the most intriguing aspects is their quasi-periodic nature. We're still developing the methodologies and frameworks we need to understand what causes QPEs, and Ansky's unusual properties are helping us improve those tools. By the way, the name Ansky comes from the visible light outburst that happened in 2019 and was labeled ZTF-19. This event was the first indication that something unusual might be happening. Then later, it was discovered that it takes place in a spiral galaxy, about 300 million light-years away in the constellation Virgo. Let's have a look at how this discovery was made. The nice thing about this research is that it was truly a joint effort. The data came from a bunch of different telescopes on the ground and in space. This included the powerful X-ray telescopes Chandra and XMM Newton, as well as the more recent one, NICER, which is on board the International Space Station. This is a relatively small telescope that fits into a 19-inch rack on the station and performs X-ray astronomy from low Earth orbit. And since it is on the station, it can point very precisely where it wants to look. All this makes NICER perfect for studying these rare events. The reason it is needed is that otherwise such events would be really hard to detect. You see, they are transient, meaning they only last for a short period of time. And in addition, the source of the light is variable, making the signal hard to find. NICER could observe Ansky about 16 times every day from May to July 2024. And this frequency of observations was crucial in detecting the X-ray fluctuations that revealed the quasi-periodic ejections. But what exactly did they find? Well, they looked at several eruptions of Ansky and found that the eruptions seemed to repeat in the same way every time. At first, there is a rather quick rise to maximum brightness, and then there is a slow decline. The entire process repeats itself then every 4.5 days. And it seems that this will keep going on for a while. But what is happening here? What is causing these quasi-periodic eruptions? Well, there is no certainty yet, but scientists think that the eruptions occur when a relatively low-mass object passes through the disk of gas, surrounding a supermassive black hole that has hundreds of thousands to billions of times the mass of our Sun. When the lower-mass object punches through the disk, its passage drives out expanding clouds of hot gas that we observe as quasi-periodic eruptions and Why are they quasi-periodic? That's because scientists think the smaller object's orbit isn't circular but slightly elliptical, and this means that it slowly drifts closer to the black hole with each revolution. After a few thousand years, it will cross the boundary of no return, the event horizon, and then nothing will be able to save it. It will get destroyed by the black hole. But until then, the extreme gravity close to the black hole warps the fabric of spacetime, and this alters the object's orbits, so that they do unclose on themselves with each cycle. Because of this, the eruptions repeat until the disk disappears or the orbiting object disintegrates, which may take up to a few years. And interestingly, in the latest paper, the researchers didn't just confirm that these eruptions exist. They also measured how much matter is ejected during them and how fast this matter is moving. And here are the incredible numbers. Every outburst ejects around a Jupiter's mass worth of material at around 15% of the speed of light. That's mind-boggling. But there is more. In the latest paper, the researchers also present a model that describes how this material is distributed in space. They were able to study variations in X-ray intensity during the rise and fall of each eruption, and this allowed them to build up a map showing how the ejected material expands over time. The results show that the material is expanding in a sort of bubble around the black hole. So the 2 papers just published are important steps in understanding these mysterious quasi-periodic eruptions. In particular, the latest work shows that it is possible to test theoretical models against observations. So if the theoretical predictions fit the observations, we will learn a great deal about these fascinating eruptions. What do you think? Does this give you goosebumps? I think it does. For me, it is always amazing to see how precise and accurate these measurements are. Just imagine what kind of computers and instruments we will have just a few papers down the line. The possibilities are just amazing. Thanks for watching. See you next time.